The uniform metal wire has a length of L is having a resistance 10 ohm. Now the wire is stretched to a length of 2L then bent to form a perfect circle. What is the value of equivalent resistance after it's forming a circle? It's given in the question. The initial resistance value of a wire is 10 ohm. It's known that after stretching, the wire is stretched to double its original length. So the resistance doubles as well because we know that the resistance is directly proportional to length. So here we can write the new resistance will be 2 times of the initial one. So 2 times 10 will be 20 ohm. So here it's given in the question, it was bending into circle. So the wire is bent into a circle. When we measure the resistance across any diameter, the wire is split into two equal parts. So each part will have a resistance of 20 over 2 ohms, which is nothing but 10 ohm. So here the equivalent resistance will be equal to 10 times 10 divided by 10 plus 10 because this is a value of R1, this is a value of R2 which will be connected in parallel. So when we are calculating the final answer, we will get 100 divided by 20 which will be equal to 5 ohm. So the correct answer for this question is option B.